Okay, for Project 3 we're going to be studying some of the transformations of sine functions. We don't get into all of them in this, but some of the more basic ones. So what we're starting with is the graph of the sine function, just sine of x. Okay, and that's what you see in green on the screen. What we're going to be looking at is some transformations that are shown up there. G of x, h of x, and we'll discuss each of those transformations as I show them on the screen. But the basic function sine of x just starts out at 0 and has a period of 2 pi. So we go from 0, it crests up to 1, goes back down to 0 at pi, goes to -1, and then back up to 2 pi. All it does is just follow the unit circle. As the unit circle goes around to pi, the sine function is going to be 0 because the sine is the y value. Okay, so let's look at the first one. First function is going to be g of x, so I'll turn that on. And what this is sine of x minus 2. Okay, when the minus 2 is on the outside of the parentheses, what it does is a shift down 2 units. So you could say it's a vertical shift downward 2 units. And so we notice that all of the points where it intersected here at 0, 0, it now intersects at 0, -2. Okay, everything is shifted down 2 units. So the amplitude, frequency, everything is the same. Okay, all it is just a straight vertical shift. The next function, h of x, is going to be sine of x plus 5, which you can see in the blue. Okay, again, since the plus 5 is on the outside of the parentheses and not on the inside, all it does is affect the y value. So because it's plus 5, it shifts everything up 5 units, as you can see. Again, amplitude and frequency are just the same, and if you look at the curves, you can see that everything, it's just the same graph, just shifted up or down from our original green one. Okay, the next graph, k of x is going to be 3 times sine x. Alright, and let me move these off real quick just to clear up the screen. So 3 times sine x, now that is going to change our amplitude or do a vertical stretch by a factor of 3. So now we take all of the y values and multiply them by 3. So before, where we had our peak here at 1, now it's going to peak at 3. Where we had a valley here at -1, now it's going to be at -3. So every y value has been multiplied by a factor of 3. Okay, so all this is going to do is just change our amplitude. Okay, our frequency is still the same. We're still crossing the x-axis at all the same spots, as you can see here where they intersect on the x-axis. So now, along with this one, I'll do our next function, L of x, which is equal to -3 times sine x. If I do -3 times sine x, it should be the same as this because this was just 3 times sine x, but that negative has a different effect on it, as you'll see here in the purple. Okay, what the negative does is it reflects it over the x-axis. So it's going to be the same graph as the orange one, as our 3 times sine x, but just reflected over the x-axis. So now when this goes to +3, the reflection would go to -3. And you can see that they come together, and that one is just a mirror reflection of the other. Okay, and then the last function that we're going to look at, or last transformation, is going to be our function m of x, which is equal to 1/3 times sine x. So now if we multiplied the function by 3 and we had a vertical stretch, multiplying it by a number that's between 0 and 1 is going to do the opposite. It's going to be a vertical compression. So now 1/3 sine x is going to take all of the y values and reduce them to 1/3 of what they are. Now notice again, frequency hasn't changed. So I'm still hitting everything same place on the x-axis, but now instead of it peaking at 1, I'm only going to peak at 1/3, and instead of going to -1, I only go to -1/3. Okay, so that's the effect of multiplying by a number between 0 and 1. Now I'm going to bring all of the graphs up. Okay, now remember our original graph is the one in green. Okay, and if I change this graph, if I do anything to it, it's of course going to affect all of the graphs that are dependent on it. Why? Okay, because they depend on the values of this function. So if I do a horizontal shift, left or right, you can notice that every function also shifts left or right. Okay, if I change the amplitude, okay, it's going to change that way. So any little thing that I do is going to affect every graph that's dependent on it. So those are just some of the basics of sine graph, or even if we had done it cosine graph or just trig function transformations.